Hello friends, this is Durga again from Technology Mentor / IT Varsity, and as part of Map Reduce application development, we using Hadoop APIs. We have seen so many things starting from default map reducer behavior to complex map reduce applications covering the entire life cycle of it. And lately we are talking about partitioning the data, and as part of the last video, I have given overview about partitioning. And in this video, I will take it to I will take it further and try to explain you how we can leverage the hash code and or to develop a custom partitioner to change the behavior of partitioning the data. That being said, let's straight away go into the code, and in this case let's define the problem statement. The problem statement is that we want our data to be grouped together by stock, which is the second field. Okay, and okay, this is the problem statement. We need to make sure data is partitioned by stock ticker so that all records related to particular stock are written to one file. Okay, and for that, let's see how we can tweak the hash code. So we want to use the stock ticker, and using the stock ticker we want to partition the data. So for that, what you can do is you can just comment out this line where for our text pair object, instead of computing hash code on the combination of both the fields, we are ignoring the first field and computing the hash code only on the second field. Okay, so now our hash code will be computed only on the second. So using this, the mod function will be applied. So for Bank of America, for any given month, it will generate the same hash code, and it will go to the same partitioner, which will eventually go to the same file. Okay, so, that being said, now let us see how we let us validate that. I am rebuilding the package, and then I am copying to the cluster. Okay, now I am logging into the cluster. It's a single node VM, as you have been seeing for all these days. And now let me run this command hadoop jar and ysc minus, and nothing is changed to invoke the program. Let me replace the directory name so that it goes to a new directory. So it will just take a moment, and then we will review the output. So it is done. So let me do the cat. Sorry, first let me do the ls. So now you can see that data is only distributed into two. The reason is we are only invoking this program for two stocks, Bank of America and Apple. And then we can actually validate the data itself. Two. You can see that all Bank of America stocks are together, and also you can see that it is sorted by month, and I will explain why it is sorted by month when we talk about sorting. But for now, just focus on the second field, and the data is actually all the data related to a particular stock is written to one file, because of that small change in the behavior of the hash code. Okay, and now shall we do this? No, the answer is no. You should not directly modify hash code unless and until this custom key is developed for particular use case. But in our case, our text pair is a generic one where we can use it anywhere, not only with the New York Stock Exchange application but any other application. So modifying this directly can impact many other things if it is used in other applications. And also, even if you have just started from scratch, if you modify this, then you cannot use this elsewhere. It has to limit it to your New York Stock Exchange application because it is only considering the stock ticker. Okay, for that reason, we should not modify the hash code and play with it to change the behavior of the traded month or stock ticker. You can just play with this and get that behavior. For example, instead of Bank of America, if you want to distribute by or partition by traded month, you can uncomment this one and comment this one, and then data will be sorted or so data will be partitioned by the traded month. But we should not play with this. Instead, we have to come up with a custom partitioner. Okay, so for that, let us create a new class, and I'm creating a new package altogether for partitioners. Finish and then new class. So in this case we want to do it on the second key, and I want to make it generic. So let me say second key text pair partitioner, because out of the text pair I want to partition by the second key. That's why I'm using this function. We can make it more generic also, but it's a little bit more complicated, and I don't want to get into that. And to create our custom partitioner, we have to extend the abstract class partitioner, and we are trying to develop it for text key of type text pair and value of type long pair. You have to specify what are the types you are trying to use while developing this partitioner as part of the specification of the extended class. Okay, I'm just importing all the classes, and now it is complaining that we have to add an implemented method, and we did that. And here what you have to do is, so it returns integer. Okay, so let's define an integer. Let's partition value. Okay, let me initialize it to 0, and now what you have to do is you have to do partition value equal to, so we have, using the key, we have to get the second method. So we have the getter for the second object. So as part of the text pair we have two fields, first and second, because it is generic we named in that way. And for the first and second we have getters and setters, and we are using the getter for the second field, which is called as second, which is represented by this, and then we have to get the hash code for it. And hash code, so second is of type text, so by using this it will go to the text class and will get the hash code based upon the logic defined in there. So for that, let's go and search for org.apache.hadoop.io.text. We are actually going to the source code of the text provided by the MapReduce APIs. Click on the version you are interested in, and there is a method called hashCode here. Okay, and here it is invoking super hashcode. So text actually extends some binary comparable, which is it extends binary comparable and implements writable comparable. And I don't know, probably when it says super of hash code, this binary comparable might have that hash code. Yeah, so here you have this hash code, and what for text what it is doing is it is actually getting the binary convert getting the hash on the binary of the text. So that's why it is a little bit more complicated than other numeric types. So using this logic, it will actually compute the hash code, which is defined in text class, which is extending binary comparable and have the definition for hash code. That being said, we will get the hash code based upon that, and after you get the hash code, you can actually do the bit operation as it is done in in the existing hash partitioner. Probably it might be more efficient, that's why they might have done that. And then we need to apply the mod function on the using the number of partitions. And how this number of partitions will be passed? It will be passed by the framework itself, and it uses the number of partitions defined in our driver class. So whatever is defined here, this will be passed by the framework to our partitioner if we start using that partitioner as part of our map reduce application. And then we have to return this one. And I saved it, and now I have to use this partitioner as part of my program. So go to the driver, and here instead of partitioner class, which is hash partitioner, I want to use second key text pair partitioner, which is just defined, and I have to import it. Once imported, you can build the package and then FCP it to the cluster. And log into the cluster. And then run this program. I'm giving a new directory for this. While it is running, you need to first evaluate the existing partitioners. If the functionality cannot be done using the existing partitioner, then only you should write this custom partitioner. And custom partitioners not only can tweak behavior like this, you can actually implement other logics also, which we will see in a moment after this is done. But this is how you these are the typical steps to write the custom partitioners. Now if you do ls on this output directory, which is 5 for our last run, you can see that data is divided into 4. Let's see, something is wrong. Sorry, I have to do the cat. So it didn't work as expected. So something is wrong. Let me see the class here. partitioner is second key text partitioner. Let me go to the okay, here I have to use text pair comma long pair. So that is not the case. I don't need to specify here as text pair and long pair, so I have deleted it, and something is wrong. So yeah, I think I have not saved the file last time, so let me save it and now try it. Let me try it. So I click on pom.xml, click on run as maven install, and now let me do the scp. Hadoop is the default password for Hotnox VM, so I'm using the same thing. Logging into the cluster now, Hadoop, and then I want to run it again. I just change the output directory, hit enter. It will just take a minute, and then we will review the output. I think it will work this time. It is done. Now let us do the ls. We want to do it on 7. Hit enter. Sorry, it's ls. Hit enter. And you can see that now only the first one and fourth one have the data, and the second and third one does not have. As we have 2 stocks and we are trying to partition by stocks, it makes sense. And now you can actually do the cat and then part minus r minus 5, hit enter, and you can see that all the Apple stocks are in one file because it is partitioned using the second key in our composite key, because we have developed this second key text pair partitioner. So to recap, what we have done is we have seen how we can change the behavior of default hash partitioner by changing the hash value function as part of our custom key, and but that is not advisable because a text pair is created for generic keys wherein you want to have composite key with 2 text fields, and if you just try to compute hash code only on one field, it might impact elsewhere. So you should not modify hash code directly, even if you can get the desired outcome. One way is you can have a specific custom key for your application. In this case, instead of having text pair, you can say New York Stock Exchange pair or something, and you can have whatever hash value you want to compute out of it as part of the hash code. And then you can actually write a class for extending partitioner where you can define your own partitioner logic. In this case, we are trying to get the hash code of the second key of our composite key, and then apply the mod function using num partitions. And for that, you have to extend the abstract class called partitioner with the specification defined using our map output key and map output value types. Okay, so this is map output key and map output value. Using that, we need to override get partition function, including number of partitions, and then you can have your logic, whatever you want. So this can be used to simulate the range partitioning. You can have rule-based partitioning also. So you can play with this and you can do a lot of things for partitioning. I will try to cover another partitioning program which is a little bit more complicated to simulate range partition as part of the next video. But by now you should have fair understanding about how the data is partitioned as part of the shuffle and sort, by default, and how you can tweak it to get the desired outcome. And it can give a lot of benefit doing so, because once we start grouping partitioning based upon a particular value or particular part of the key and get all the values related to that, there are some other downstream components in shuffle and sort phase itself, which you can leverage and write more complicated map reduce programs with very small amount of coding. We will see such type of use cases going forward, but for now just understand how the data is partitioned and how it can be tweaked as per our requirements. That being said, I hope you are enjoying the content so far on my channel. If you are not subscribed yet, please do so. If you like a particular video, please click on the like button. If you want to provide feedback or ask any technical question on a particular video, please do so leveraging the comment section of the video. That being said, thank you.